What we're going to be explaining today is how an audio amplifier works. Right here I have a Class D MOSFET amplifier. Runs off a 12-volt DC source, and it takes the sound signal from the stereo deck, amplifies it to a 500-watt RMS power output, and sends it to the speakers to play the song. Now we're going to go inside and explain the internal processes of this amp. So this is a basic block diagram of the amplification process. The input, the 4-volt analog input, goes through the pulse width modulation process. From the PWM it then goes to the MOSFET amplification process. That signal that is generated between these two processes is then put through the low pass filter to get rid of unwanted frequencies, and then it is played through the speaker. Now this amplifier is a Class D amplifier. This is the most common amplifier used for audio applications because it is 100% efficient and it generates very, very low amounts of noise during the amplification process. Now what we're going to do is break down and explain generally each process of the amplification. The pulse width modulation process takes the input signal, input analog signal, puts it through a comparator op-amp circuit, and compares the input to a generated triangular waveform, like this. The output signal generated is a series of pulses and widths that vary proportionally to the amplitude of the input signal. Next step to the process is the amplification process, where the amplifier takes the PWM signal and amplifies it into a bigger PWM signal, or a bigger digital signal. Now, for the amplification process, most amplifiers use a BJT transistor, whereas this amplifier uses a MOSFET transistor, or a metal oxide semiconductor field effect transistor. Now, it performs the same basic function as the BJT, but they act as switches. So when the positive half of the cycle is on, Q1 is on and Q2 is off, and then in the negative half of the cycle, Q1 is off and Q2 is on. So those two add to each other to create a more amplified signal going through the low pass filter. The advantages of using the MOSFET transistor over the BJT transistor is that there is zero power dissipation in this entire cycle. Therefore, the power gain throughout this amplification process is at a maximum. And because there's zero power dissipation, the amplifier is 100% efficient, as I said earlier. So that is why that in digital applications, or a lot of audio applications, they like to use the MOSFET transistor over the BJT transistor. The signal that comes from the amplification process is an amplified PWM signal. But what actually is in this PWM signal is both the original triangular wave and the original audio wave. But both of these got amplified in the last step. So when this signal goes into the low pass filter, it cuts out the triangular waveform and just leaves the amplified audio signal. And it does this by capacitors and cutoff frequencies. So as an overview of the entire amplification process, we took a 4-volt analog input, put it through a pulse wave modulation process, which translated the analog signal into a digital signal. The MOSFET took the digital signal and amplified it and produces power gain. The low pass filter then takes the amplified digital signal and takes out the triangular part of the PWM signal and leaves us with the amplified original audio signal that the speaker plays. And that's how a MOSFET Class D amplifier works.